Hi all. Groundwater vulnerability status of natural recharge zones in the Airur River Basin, Kerala is my study topic. This is the introduction regarding my presentation. Groundwater is one of the valuable resources due to increase in the population, industrialization and agricultural practices. The groundwater stress has increased to a greater extent. The problems associated with the groundwater are many. While overexploitation and contamination of groundwater have been a subject of global concern. Once the groundwater gets contaminated, remediation is very difficult. The steps to measure the groundwater vulnerability must be taken for sustainable groundwater protection and management planning. Groundwater contamination risk assessment is an effective tool for groundwater management. And this is the two important objectives of my study. First one is to identify the zone of natural recharge within the Aidur River Basin by using SALDIT model. To identify the groundwater vulnerability zones by using drastic model is my second objective. This is the study area Airur River Basin, which covers an area of 112 square kilometer, and this is a digital elevation model of my study area having elevation ranges from 0 to 125 meter. The study area lies in between north latitude 8 degree 50 minute 2 seconds, 8 degree 43 minute 30 seconds and east longitude 76 degree 39 minute 32 second, 76 degree 49 minute 44 seconds. The study area is situated in the northwestern part of Trivandrum district and southwestern part of Kollam district. The basin Airur is a small basin which drains both the crystalline and sedimentary formation. This is the methodology flowchart prepared for easily grasping what are the data sets used for the study and what are the models or methods implemented for the study, also about final result. Here four major types of data is used. First one is satellite data. Here Landsat 8 data is used, which is used for digital image processing techniques and land use plan cover preparation. Toposheet and auxiliary data is second data set, which is used for the following: geology, geomorphology, drainage, soil texture, etc. And the Aster DEM data is mainly used for creating slope and relative relief map. Here, field data is used for water level fluctuation identification. Well inventory data is used for that. After the collection of all these data types, SALDIT model analysis done for the identification of natural recharge potential zone, and also use these data types for drastic analysis to identify the groundwater vulnerability zones. And in this, source, data types, file type and other details of data sets were included, and also rainfall data source is included. And this is also shows the data sets and its corresponding source. And this one is the land use land cover map of my study area, in which is mainly concentrated with agricultural lands and vegetation. More built up area is mainly concentrated along the northwest to southwestern part of my study area, and this is the drainage map of my study area, and here fourth order stream is present. Relative relief map of Airur River Basin. Here the lowest relief is 18 meter per square kilometer and highest is 83 meter per square kilometer. the actual variation of altitude in this unit area with respect to its local base level. This is the table which will shows weightage and ranks assigned for different ranges of solid parameters. We know that the terrain having highest slope will have least percolation and highest runoff. So here we will assign the rank 1 for the lowest sloping and rank 5 for the highest sloping area. Same ranking system is used for aquifer specific yield also. In the case of sand percentage, the highest percentage of sand occupying area will have rank 1 and lowest percentage of sand occupying area will have the value 15. Depth to water level, pre-monsoon data is used for the study. The highest depth will have lowest ranking and vice versa. Here, influence of geology and topography are the two parameters will have more importance for the recharging of the terrain. So, we choose 6 as the highest weightage for those parameters. For finding natural groundwater recharge zones, we need SALDIT model. SALDIT is the combination of 6 parameters. These are the 6 parameters used for the study of SALDIT model. First one is slope of the ground, aquifer specific yield, land and soil cover. Instead of land and soil cover, sand percentage is selected for my study. Depth to groundwater table, influence of surface geology, topographic features of the location. And SALDIT index is calculated by using this equation in which Wi is the weight of ith parameter and Ri is the rank value of ith parameter. This equation is used for the identification of maximum and minimum SALDIT index score. I will get the maximum SALDIT index score as 7 and minimum as 1. This is the table which will shows weightage and ranking assigned for different ranges of SALDIT parameters. We know that the terrain having highest slope will have least percolation and highest runoff. So here we will assign the rank 1 for the lowest sloping and rank 5 for the highest sloping area. Same ranking system is used for the aquifer specific yield also. In the case of sand percentage, the highest percentage of sand occupying area will have rank 1 and the lowest percentage of sand occupying area will have the value 15. Depth to water level, pre-monsoon is used for the study. The highest depth will have lowest ranking and vice versa. Here influence of geology and topography are the two parameters and will have more importance for the recharging of the terrain. So we choose 6 as the highest weightage for those parameters. These are the maps developed by using SALDIT parameters. In this case of slope map, here the major part of the area is under low slope, that is 0 to 7 degree. It will indicate that the river basin is more or less flat terrain. Very few terrain is under deeper slope. In the case of specific yield, is comparatively low and except an area. In the case of sand percentage map, majority of the study area lies under 51 to 68 percentage ranges. And depth to groundwater table, here I choose pre-monsoon data and is two regions will shows the highest water level, which is ranges from 23 to 29 meter. And in the case of geology, geologically the study area is mostly under or covered with sandstone and clay with the lignite intercalations followed by condylite and pegmatite complex. And geomorphologically the basin is under lower plateau. These 6 layers are reclassified with the corresponding ranks and SALDIT index score. Calculation is done with it, and finally we will generate the groundwater recharge area map. In this map, around 63 square kilometer area is under moderate recharge potential zone category and having SALDIT index ranges from 3 to less than 5, and followed by least and high potential category having an area of coverage 29 square kilometer and 14 square kilometer respectively. Two regions are under very high recharge potential category. One is on the southern tip of the basin and the other was on the central part. Almost 6 square kilometer area is covered with this zone. And delineation of groundwater vulnerable to contamination zone, we need drastic model. In drastic model, we uses 7 environmental parameters. First one is depth to water level. Here I select post-monsoon data as depth to water table. Net recharge, aquifer media, soil media, topography, impact of water zone and hydraulic conductivity are the other parameters. Drastic index is generated by using this equation. That is the sum of the product of rating and weight of each parameter, where R is the rating value and W is the weight assigned for each parameter. This table will shows the range, rating and index of drastic parameters. Here depth to water level and impact of water zone will have highest weight, that is 5, followed by net recharge which will have weight 4. Each parameter ranges will have corresponding rating values and weight, which when these rating are multiplied with weight to get index values, reclassified by using these values, and finally we'll get the maps. And this is one of the parameter map used for the study. Water zone is a parameter. Corresponding rating and ranges rating and index values are depicted on this map, and these are the other maps used for the study, and each map will shows the ranges and rating and corresponding index values. Index values were calculated by multiplying rating value with each parameter weight. And depth to water level map will prepared by using post monsoon data, and net recharge is prepared by by combining soil map, slope map in percentage with the rainfall data by simply using weighted sum. And aquifer media map, hydraulic conductivity map and water zone maps show similar in feature, but it is different with its rating and index values. Topographic map is here, slope in percentage map, and this is the final map in which the groundwater vulnerability zone is divided into three categories, ranges from 55 to 197. The low vulnerable zone ranging from 55 to 138 and having an area of 34 square kilometer. Low vulnerable zone mainly concentrated on the northeastern part of the study area and on the water body region. And moderate vulnerable zones ranges from 139 to 181 with a 37.85 square kilometer is disseminated all over the basin, and the larger patches on the southern part of the basin. Highly vulnerable zone ranges from 182 to 197 with 37.62 square kilometer and is mainly concentrated on the northwestern part of the basin. These are the conclusions of my study. Alluvial areas are more susceptible to aquifer contamination. The shallow water level and high hydraulic conductivity favor the contamination. Most part of the highly vulnerable areas are under moderate recharge potential category, and finally area under very high recharge potential zones will show moderate vulnerability. Thank you.